All right, so let's go ahead and actually do some NumPy coding, okay? So as we were going through the slides, and I'll ask you to make sure you have your slides up and ready to be sort of looked at and referenced fairly quickly. We talked about sort of the idea of creating these lists directly from an array. Okay, so let's go ahead and just establish this idea that I can convert a list into an array. Okay, so we're going to create something called nums. It's nothing more than a list. We're going to give it some numbers. There we go. 1, 2, 3, 5, 6. Okay. So using NumPy now, I can actually convert that into a NumPy array. So I have all the powerful functions of NumPy ready for me. Okay. So to do that, I could call this, say, np nums, and I can set that equal to np.array. And then I can just throw, oh, not np. Let me adjust this real quick as np. And then I can just throw my nums array right in there. Okay, so to establish that this actually works, we can actually just use the print function, and I can throw np_nums in there, and when we run this, now you're going to go ahead and see that the NumPy array will print. Okay, 1, 2, 3, 5, 6. Okay, so you can do that explicitly as well, like we showed in the slides. Okay, so I can do np_nums2, np.array, and then I can actually create it explicitly inside here, you know, 3 or 2, 3, 4. Okay. So again, now if I run a print function, I can actually print np_nums2, and you'll see now that I can actually do it this way as well. Okay. So please follow along if at all possible, because it's going to help you with your exercises. Okay. So again, we can also explicitly sort of define what kind of a data type that we're talking about. Now, again, when we talk about data type, as I've said many times, don't get overwhelmed. Don't be sort of freaked out about the idea of data type. All they're saying is it a number that is, so is it a really big number? Is it not a really big number? Does it have a decimal or not? That's all it's sort of telling you. Okay. So let's say that I want this one to be sort of explicitly of a float. Okay. So I can actually go with a float there. And now when it prints, you're going to notice that there's going to be a differentiation. Okay. So now it's 2 point, 3 point, and 4 point. So that's telling us I created an array, 2, 3, 4, out of floats. Okay. So it converted the 2, 3, 4 that are integers into floats. And that's essentially what we're doing there. Okay, so we can actually create those arrays from things that we've already done. Maybe we've been doing some calculation in Python. We built out a list. Now we want to push that into the NumPy package and use all the powerful stuff that it has. And we just want to do that. That's a great way to do that as well. Okay. Now, if we're going to be starting from scratch, as I mentioned earlier, we can actually use the np.0's and np.1's functionality as well. Okay, so we can call this one ones, and we can call this np.ones. Okay, so that's the np_ones. Now, we can do, you know, just say 12, and we can say it's a d-type int. Okay, so we could do that example. Okay, so if we sort of unpack this from what we know, this should create an array, a single-dimensional array, excuse me, a single-dimensional array with 12 ones in it. Okay, and they should be of the data type of integer. Okay, so if I go ahead and print this out, I can print ones, and now you can see, there we go. I have my ones. Okay, now we also mentioned that we could do multi-dimensionality. Okay, to do this, we just create a tuple, and I give it how many rows I want. Let's say 4 rows, and let's go with 5 columns. Okay, so now you're going to see 4 rows, 5 columns, and let's say I actually want this to be a float. Cool. So now we're actually going to have 4 rows, 5 columns that are floats. Okay, now we also have the zeros option. Okay, so zeros. We can also do that with zeros. Notice how these ones are floats. If I convert this to an int, it'll go ahead and create them as integers. Okay, so this is an extremely powerful tool because I can sort of build these very, very large, technically, data sets very, very quickly. Okay, so now this is showing an abbreviated version of it, but that is a 40 by 50 array right there is what that is. Okay, so that is sort of creating with the ones and the zeros. We could also do the idea of the full. Okay, the full is just changing your function call, and full is just allowing you to put some number. I don't know what you like, but I have a favorability to the number 42. So what I could do is I can actually create a 2-dimensional array of 4 rows, 5 columns with the number 42 filling all of it. And there we go, 42, 42, 42. meaning of the life, the universe, and everything. If you know, you know, right? Okay, so that is np.full. So 4 rows, 5 columns filled with the number 42. And then we have this arrange concept as well. Okay, so if I come down here and I create, let's just call it ARR1. And we're going to use np.arrange. Now, if we remember, arrange acts exactly like the range function. So let's say I wanted to start at 5. I wanted to count up to, say, 59. And I wanted to count by 5s. Okay, so if we evaluate this, we'll go 5, 10, 15, 20, 25, 30, all the way up to 55. Actually, we could say 60 just to test it. This is non-inclusive in the range because it's just basically the range, right? Okay, so it'll go 5 all the way up to 55. And if we go ahead and print that out, AR1, we should see that we get from 5 to 55 in our particular array. Oh, I misspelled it because, you know, I'm a coder, not a speller. That's how it works. Okay, so there you go. 5, 10, 15, all the way through 55. Okay, so that's the arrange function, the full function, the ones function, and the zeros function, making sure that you get your data types in there. Again, an integer is just a whole number. A float is just a decimal. Okay, you can also do the full where you put whatever you want in there. And then you can also do your np.arrange. Okay, so one of the cool, I'm going to kind of delete these here a little bit just so we don't overload too much. We can also do this linear space idea. Okay, so I'm going to call this linspace, and we're going to explore the linspace call. Okay, so if you recall, it's sort of give it a range. Okay, so to start with, we'll go from 0 to 2. And then I give it how many values I want inclusive. Okay, so let's say 20 values. Okay, so now if I take linspace and I go ahead and print that, and actually let's go with less so we can validate that. We'll go with 5 values. Okay. All right, there we go. 0, 5, 1, 1, 5, 2. 1, 2, 3, 4, 5 values. 0 is included. Okay, so obviously if I up that to 10, you're going to see it divide that space up into 10 from 0 to 2, 2 inclusive, 0 inclusive. So we got 2.222, 0.444, 6, 8, whatever. Okay, you can see that you can create this linear space of evenly distributed values between two numbers. Okay, so that's what the linspace, that's where the power of linspace actually comes from. Okay, now again, we do have this idea of a random. And this is actually really fun for machine learning or building video games or building simulations. You can create sort of random vector spaces really, really efficiently with this idea. So np.random.random, and then I can just sort of give it a tuple of, you know, how many rows and columns. So we'll do 4 rows and 5 columns. And then I can go print random. And you'll see that I get sort of this random chunk of numbers, okay, in there. Now, notice these numbers are decimals, okay? So it's going to go from 0 to 1 is what that's going to give me, from 0 to 1. So if I add, you know, 8 of these, you're going to see from 0 to 1, 0 to 1, 0 to 1. Okay, that's not going to actually give you any other sort of distribution. This is giving you a random value from 0 to 1. Now, if you want to create random values from 0 to 20, you can actually use these as multipliers. So from 0 to 20, then you take, let's say for this first one, you would take 0.68 times 20 and then convert that to an integer to give you the number that you actually have. Okay, so it takes a little bit of mathematical finesse, but it's just fine. It's not a big deal. In general, when we're doing data and analytics and we want to do something like this, we want some sort of a distribution between 0 and 1. All right, we can also explore this idea of the np.random.normal distribution as well. Now, the np.random.normal is going to create sort of a normalized distribution and like a normal Gaussian distribution. Okay, so in statistics, normalized Gaussian distribution is actually going to give you sort of this idea of a bell curve, right? And the 3 different parameters that we have, the first one's going to be the mean center of the distribution, right? So if we go ahead and use normal, I can actually put in the number 0. Okay, so that what I'm saying at that point is I want the mean center, like the mean of the distribution, the center of the distribution to be around 0. Okay, so I'm saying 0 is the center of my sort of bell curve there. Okay, now the next one that you're going to get is actually the standard deviation. Okay, sort of like the spread of the values inside of it. Okay. So we could do 1, we could do 2, whatever. So if we want to choose a standard deviation of 1, there we go. So now we have standard deviation of 1. Okay, then next we just want to go ahead and give it a sort of rows and columns. So we want to go ahead and give it a size. Okay, so this means the mean or the center of my distribution is going to be at 0. I'm going to have a standard deviation of 1. I'm going to have 4 rows and 4 columns. If you haven't taken statistics, all this will make sense once you take statistics. If you have taken statistics, you can see how kind of powerful that's going to be, which is pretty stinking cool. Okay, so there you go. We have our center sort of around 0, but you can see that the standard deviation is used to go ahead and move that around across that distribution. Okay, so that's sort of what the normal is. It's going to give you a Gaussian distribution. We also have this idea of the np.i, which is super duper cool. We'll just call it I, np.i. So if you've done linear algebra and you like to solve linear matrices, right? So you can actually solve a bunch of polynomial solution. You can solve a bunch of polynomial equations all at once using sort of vector math. And NPI can kind of set you up to be able to actually do that kind of stuff. So if we want to do an np.i, it's going to go ahead and just sort of give us the foundational architecture for that. So let's go ahead and print that. Print I. Boom, there you go. Okay, so you can see now I just have that diagonal at 1s. So I'm basically sort of starting with my polynomials being 1, you know, which would be x. It would be x cubed, x squared, or it would be x to the 4th, x to the 3rd, x squared, x, and then just the regular old c. Okay, so there we go. That's essentially what you're getting on your np.i there. Okay, so essentially in most of these, you can actually, some of these are explicitly defined in terms of data type. Okay, so obviously linear space, if you're going from 0 to 2, and you're going to break that up into 10, obviously it's going to have to be a float. The random or the normal distribution or Gaussian distribution has to be a float of some sort, right? So if you just use float, it's going to be a 64-bit float. But most of these you can actually, you know, in the 1s and the 0s and the full, you can actually delineate an actual data type for those. All right, so in the next video, we're going to jump a little bit deeper in terms of sort of some of the things that NumPy arrays can do, talking about, you know, attributes, indexing, slicing, reshaping, and stuff like that. All right, so stay tuned. We'll see you in a little bit.